Hey, good to see you again. We're just about to look at the day 3 challenge on Advent of Code, and I have to say I'm so excited about this one because I think it's going to be a really good opportunity to illustrate some of the functional programming concepts that we really want to talk about. In terms of the themes we're going to cover today, we're going to talk about more recursive functions. We're going to talk about the modulus operator, also known as the percent symbol, and we're going to talk about the concept of higher order functions. So let's go ahead and get started. We'll take a look at what the problem is asking us. And as usual, we have a wonderful story that the problem is wrapped in. Basically, what it boils down to is that we've got kind of a field represented as a grid of characters. So they're either dot characters, which are sort of like safe, or they're hashtag characters, which are unsafe, I guess. They're dangerous. Anyway, the point is we start in the upper left corner and we're going to go down 1, right 3 on each turn. And basically we just want to check, hey, is there a hashtag there? Or, is it safe or is it unsafe, basically? So is it a hashtag or is it a dot? Okay, so that's basically what it boils down to. Now, one other thing that's worth mentioning is the fact that we've got this original field that we're given, right? But then we sort of have to recreate it several times. It repeats is basically the idea. So we need to get all the way from the top to the bottom. And as you'd notice, if we're going down 1, right 3, we'd basically reach the right edge of this before, well, actually long before we get to the bottom. So that's why we sort of recreate this thing. And then they show us a diagram here of all the spots that we would end up visiting. And we see basically that there are 7 locations here on our travel to the bottom. There are 7 locations that would encounter a hashtag. And so that's basically the answer that we're looking for. How many times would you encounter a hashtag? Now, of course, our actual puzzle input is going to be a lot more complicated than this. We could take a quick look at it. There it is. Okay, so keep in mind, all of this is going to end up being repeated several times, right? That's not it that we were looking at just there. Okay. In the sense that, we're going to have to go all the way from the top to the bottom here, repeating this several times, is what I'm trying to say. So it's going to be a pretty big field. Okay. So I think we're understanding what the problem is asking. Let's go ahead and start to talk about how we would tackle a solution here. So I've already copied in just the sample field that we were given over here. In terms of the full sample input, I'm going to do the same strategy as the previous one. So basically, I'm just going to work with this smaller sample inside the IDE. And then when it comes time to actually answer the question, we're going to do it within the console window of the browser, just so that we can make a direct fetch request to get the data. Okay, so basically for now, let's just switch over to the IDE. So in terms of how we're going to do this, basically we talked about the idea of a map before, right? We talked about the idea of something that creates a new array that's the result of going through an existing array and making some kind of modification to each entry. So basically, that's what we want to do here, or at least that's what we're going to start with. I want to show how we would actually increase the size of this field to make it big enough for us to do the traversal we're looking for. So I'm going to say const big field is going to be assigned the value of field.map, and then for each row, keep in mind the rows are strings. This could have been a two-dimensional array or a matrix where each one is an array, but right now they're represented as strings. So that's actually really convenient because we have a string built in that we can use called repeat. I'm just going to say repeat 3. And the idea is that now this should include not just one instance of this field, but several. So take a look at that. Looks like it's repeating. That's kind of the pattern that we're looking for over here. So that's good, I think. Yeah, seems good to me. We could repeat more times than 3 if we wanted to. So let's just run that, and yeah, 5 times. There we go. We've got 5 copies of this thing now. We could even sort of we could try to account for what number we would need to put in here in order to make the field big enough. So for example, we could say, I'll just call this scale factor. It's nice to use variable names that are sort of semantic and represent the thing we're trying to actually come up with here. So I'm going to say field.length, and keep in mind field.length is like the vertical length of it, right? It's how many entries are in the field array. And I'm going to say divide that by field at 0 dot length, right? Because that's how many characters there are in a single row. And, you know, we probably want to modify this as well, where we're keeping in mind that we're going right 3 each time. So because of that, I think we'll need to multiply this by 3 as well. And you know, we'll talk about how we'll modify this if it was like a different ratio. But basically, this could give us some kind of a weird fraction. So just to make sure we're getting a whole number, I'm going to say math.ceil. Okay, so math.ceil is a lot like math.floor. Instead of rounding it down, it rounds the number up to the nearest whole number. I just want it to be a whole number so that we can put that in here for our repeat. So that basically it's going to tell us how many times it repeats the field. So hopefully this works okay and we get the right number of repetitions. Yeah, it looks like that's enough to sort of go through this whole field here. Okay, so let's go ahead and do that. We might as well, let's revisit our strategy. We might as well solve the problem, right? We might as well make it work for now. And then we'll talk later about how we can make it more efficient. And then of course, how we can make it beautiful and functional and all those nice things. So since we're not starting with the obligation of making it functional, let's just go with some kind of boring loop strategy. So we'll say let row and column be assigned the values of 0 and 0 respectively. So there are a couple of things going on here. The first thing is that there's a destructuring assignment, right? So this is equivalent to saying let row be assigned the value of 0 and let col be assigned the value of 0. It just sort of respectively joins these things up in terms of their assignments. The other thing is that I'm using row and col as variable names here instead of like an x or y. I want to make it as clear as possible to the reader. We don't want to have to we might get confused if it's x and y because like technically the first coordinate we're going to use in a matrix is going to be the vertical coordinate, which is more like y. So anyway, row and col, I think these are good variable names to use for the indices of some sort of two-dimensional structure, whether it's a matrix or an array of strings. Anyway, okay, so we've got row and col, they're 0 and 0. And I think we basically just want to do like, yeah, kind of a loop, right? I'm going to say while row is less than field.length. Let's just go with that for now. And we're going to do some sort of row plus plus at the end. And we're also going to do col plus equals 3, right? Because we got to go down 1, right 3. And then basically, we'll just have some sort of counter. Let count be assigned the value of 0. And then count is the thing that we're going to return at the end of all this. So we'll say if field at row, actually, we need to be checking big field, right? Because this is the one that's been copied over enough times that we're not going to go out of bounds when we try to do this, row and col. Okay, if big field at row at col is equal to hashtag, then we're going to say count plus plus. And then we're basically just incrementing our indices over here. We're checking the condition that it's still within the right bounds. And then basically, eventually, it's no longer going to be within those bounds. And so we'll move on to this console log. And I'm just going to console log what our count is right now. And I think the answer to this question is supposed to be 7. Yeah, there should be 7 trees over here. So we'll see if we get 7 with this. We're going to save it. And let me just unlock that so that it scrolls down. And yeah, there we go. We got 7. Okay, great. So congratulations. We found a way to make it work. The problem is this could be really inefficient. So we've talked about time complexity a little bit in previous challenges, the idea that we don't want to repeat calculations that we don't have to, whether we've already computed them or whether we just know they're not going to produce the right result. So we've talked about time complexity in terms of algorithms. This is an interesting case because what's more relevant in this problem is the idea of space complexity. So in this case, notice like I'm creating this big field thing, and that could be huge. Like keep in mind the size of our input here, right? Like this was many, many lines long. We'll probably count how many it is specifically when we move on to that part of the problem. But all I'm saying is like that could take a long time to basically reproduce that entire big field. So ideally, we want to find a way to do this that doesn't require us to actually reproduce the field, because that's storing a lot of new stuff in memory, right? That could really slow us down. So we want to be efficient both in terms of our time complexity and our space complexity. So I want to return to the problem here. And there's basically something I want to say about this, okay? So a great programming instinct that you should definitely have, okay? This is for any type of programmer, this is a good instinct. And look, I know there are lots of different types of programmers, but anytime you're looking at a problem like this that has some sort of a periodic cycle, okay? A cycle that keeps repeating and it's the same every time, what should instantly occur to us is modulus. Okay, so if you're unfamiliar with modulus, basically it's the percent symbol, at least in JavaScript, it's the percent symbol. I made a bit of a demo here, so we can talk about this in just a sec. I'm just going to clear the console just to clean this up a little bit, and let's just go ahead and full screen this. So basically, I just made this really quick to demonstrate what modulus is all about. So the simplest way to think about it is that if we have something like this, the question we're asking, 5% 3, is if we were to divide 5 by 3, what would the remainder be? Okay, so not the answer, not the quotient. We want to know what's the remainder. And that might seem a little weird, but yeah, basically the idea is that in this case, it would be equal to 2, right? We divide 5 by 3, it goes in 1 time, so the quotient would be 1, the remainder would be 2. You remember doing long division? That's basically what we're talking about here, right? Finding the remainder. Okay, so that might seem kind of strange, like why would you want to do that? So let's take a look at this demo. So I wrote this function, it's called display mod sequence, and basically it just takes 2 inputs. It takes the mod value we're looking for, and then there's this I value that it has a default value assigned to it, so we don't actually need to provide that one. So on every step, we're going to do a console log of I. Well, actually, this is a template string, so this is basically just showing us. It's going to say I percent symbol, whatever the mod value is equal to whatever it's equal to, right? I percent mod. So this is where we're doing the actual calculation, and then we're displaying that within a template string. Okay, and then we've got this set timeout. So this is basically going to queue up a new event that's going to fire off in this number of milliseconds. Okay, and keep in mind the event it's firing off is basically repeating this function, but with a higher I value now. Same mod value, but a higher I value. Okay, so basically this function will fire again, and it will do a console log, and it will do another set timeout. So this is kind of interesting. It's a recursive function. It's calling itself, and it's basically scheduling up another event to call itself again. Okay, so I'm going to save this, and what we should expect is basically to just see every half second, we should see like 0 mod 7 is whatever it is, 1 mod 7 is whatever its value is, 2 mod 7 equals, etc. Okay, so I'm going to save that, and we'll run it. There we go. So okay, so far not too interesting. I mean, we get the numbers themselves. Now, an interesting thing happens at 7 mod 7. It ends up being 0. And we're maybe starting to see a pattern here. So first of all, 7 mod 7 is 0 because it divides in evenly. There's no remainder, similar to any other multiple of 7. So for example, 49, which is 7 times 7, it also has a value of 0. I'm just going to stop this for now, just so that we can follow along a little more easily. So basically, notice the results we're getting here. 0, 1, 2, 3, 4, 5, 6, 0, 1, 2, 3, 4, 5, 6, 0, 1, 2, 3, 4, 5, 6. Hey, it's a repeating pattern. Okay, so anytime we're talking about a repeating pattern, think modulus, okay? And vice versa. Anytime you think modulus, think, yeah, okay, that's going to be a repeating pattern. That can be a really interesting kind of result if we throw that into a computer-generated visualization and that kind of stuff. Okay, so basically, we've got this idea of mod. So the question is, how does that apply to this problem? How does it apply to this problem of tobogganing through these trees over here? Well, basically the idea is that this thing is repeating, right? So if we're at like the first square here of the first repetition, that's going to be basically the same as this square over here, right? This square over here would be the same as this one. Basically, we can just, or better yet, this one over here would be equivalent to this one. Like, we can relate each of these back to the first like 0 to n kind of thing. So in the same way that when we were doing our modulus of 7, we basically got the numbers 0 through 6. In the same way, we're going to get basically the numbers 0 through field at 0.length, right? Assuming this is like field at 0 right here, right? So field at 0.length is going to be like our modulus number. We're just going to repeat. We'll go all the way to the end and then start back at the start, et cetera, et cetera. Okay, so you can think of this now, instead of being like, something where we're going down this direct path on this longer field. Instead, we can think of it as something where we're going through here, and then it loops around, and then that loops around, and then we end up at the end. Okay? So if you've ever played like old Nintendo games, Super Mario Bros. 2, there's some levels that are like this. They sort of wrap around the screen horizontally. Okay, so that's basically what we want to do. We're going to revisit our IDE over here. And I hate to see a loop on my screen. That's just offensive. So we want to talk about how we can use modulus for this, and then we're going to talk about how we can make it nice and functional. Okay, so the first thing is we shouldn't have to use big field. So I'm going to delete that, and I'm going to delete scale factor, because we only really created that because we needed it for big field. Okay, so I'm going to say instead of big field, it's going to be field. And instead of row and call, it's going to be row and call mod field at 0.length. Now, you might be wondering a few things about this. First of all, why not field.length? Well, field.length would be the vertical dimension here, so that's not really the right one in terms of what we're looking for. You might then wonder, okay, why field at 0? Why not field at row, right? Because that's kind of the row we're on. Well, we know that this is going to be rectangular, so we know all of these are going to be equal. In fact, probably the best thing to do would be to say something like const limit is assigned the value of field at 0.length, and then just use limit in the future, right? Because we know these are all sort of going to be the same. We could also call this like width. Maybe that would be better, actually. It's always good to be descriptive with our variable names. It's considerate to the next reader of this code, because, hey, that reader might be you. Anyway, okay, cool. So basically, we're just going to do something like this. And notice, like, we're still increasing column by 3, and then we're just taking the mod when it comes time to actually looking at the field. Okay, so hopefully, we're still going to get that value of 7. Yeah, we did. Nice. Okay, so just one other thing I want to show here. Technically, there's a way we could do this without taking the mod here. We just say row and call. That seems a little risky, because if we just do it like this, I mean, call is going to go way out of bounds, right? Yeah, so notice we don't get the right value because, like, this is undefined. It's just going to be like, oh yeah, okay, another undefined value. That's not equal to hashtag. So basically, instead of call plus equals 3, we're going to say call is assigned the value of call plus 3 mod limit. So we'll do the mod, whoa, whoops. There we go. We're going to do the mod at this point when we're actually modifying the column value, and that way we don't need to do any additional calculation on it afterwards. So we're going to save that and run it. And now we have an issue. So let's see, limit is not defined. The limit is not defined. Okay, so let's correct that to width. Yeah, because I now do remember changing that variable name. It's all coming back to me. But anyway, okay, so I've saved that, and I'm going to run the code. Let's get our auto scroll back on. Okay, great. It is 7 this time. So we're back to a situation where the code is working. That's good. And I think we're now in a situation where the code is a lot more efficient than it was before, right? We're no longer storing like a huge additional matrix in memory. we would say that this requires like no additional space, right? So we could say that the space complexity is like big O of 1 at this point, right? We're not storing any additional, I mean, yeah, these are kind of a constant size, I guess is what I'm trying to say. So it's not like we have another big, enormous matrix that we're just putting in memory. Okay, cool. So this is nice. This is efficient. Let's make it functional. We hate seeing these loops. We hate seeing let, reassigning values. Oh, it just feels gross. Okay, so we're going to do this in a functional way. Now, at this point, just like we were talking about in terms of like programmer instincts before, we're talking about the idea of if you see something repeating in a consistent cycle, we should be thinking modulus. Now, if we're thinking functional and we want to convert a loop into something functional, right away, we should be thinking recursion, okay? It's not going to be the answer every time, but a lot of the time, it's going to be the answer. Okay, so we can sort of follow along with this. We don't have too much space here. Maybe we can make some extra space. And I'll just clear that so we're not reminded of that error we had. Okay, cool. So basically, the way we're going to do this is I'm just going to write a function called traverser. That's kind of a complicated word, I guess, but basically the idea is that this is a function that's going to traverse the field. And so the inputs of this function are going to be row and col, and then the output of this function is going to be some number. Okay, so basically I'll just write it. This is a function to find the number of trees on the field. Okay, so it's going to return a number ultimately. So the question we want to ask, like before anything else, is basically row less than field dot length, right? If it's not, we basically just want to return 0. Now, this might seem a little strange at first. I'll get into why this is going to be 0, but the short answer is that it's the same as this, okay? So this is like our count number. The count number that we're going to get from this is actually just going to be direct. Like at the end of this, I'm just going to say console log of traverser. And then that's just going to be all there is to it. Like we're just going to call this function. We're not going to have like some count variable that this is going to end up having side effects on. Like it's just going to be traverser. So basically what I'm trying to say is like all of these pieces of information, we're going to have analogous stuff in this function down here. So like for example, the row and col being both 0, like we have that already here, right? So then basically, yeah, the way count is assigned the value of 0, the initial condition for count, the way that makes it in here is this. So that might seem a little strange at first, but basically, if this is a valid row, then we can say something like const isTree. Let's just start with that. IsTree is going to be field at row at col equals the tree symbol, a hashtag. Okay. So then we can basically just say something like this: return. Return traverser. We're calling the function again, right? And we're going to return it with row plus 1 and col plus 3 mod width, just like before, okay? So I think that's looking okay. The only problem is we should decide if we're going to add something onto this or not. So we should add 1 if it is a tree, and otherwise don't. So in fact, here's what I'm going to do. Instead of calling this isTree, I'm going to call this optional 1. And basically I'll say if it is a tree, make it 1. Otherwise, make it 0. We could probably get the same result by typecasting the Boolean into an int, but I just want to be very explicit about it here. So I'm just going to keep it as a ternary. Okay, so optional 1. So basically the idea is this thing is going to either return 0 or it's going to return some other traverser of a row and col. So basically the idea is, since the only number we have is 0, we need to add on to that. So what are we going to add on to that? Well, optional 1. We'll add a 1 if it is a tree. Otherwise, we won't add a 1. Okay, so basically what this is saying is if we want to think about how this plays out compared to the other one, instead of saying row and col are 0, count is 0, we've defined width, and then let's go through this loop where we say while row is still within the field length, just like we're checking over here, we're going to check if it is a tree. If so, increment the count, and then increment our row and col, and then return the count at the end. So this is actually going to do the same thing. Hopefully, I don't want to get too ahead of myself, but basically the idea is we set row and col to 0 on the first call. Okay, is row less than field.length? Yeah, it is. So we'll calculate this. Optional 1, no, that would be a 0 because in the first coordinates it would be clear it's not a tree. So then we return traverser of 1, 3 plus 0. Okay, so if it's 1 and 3, well, let's check. No, it looks like we're clear there as well. So optional 1 would be 0. And so we say traverser of 2, 6 plus 0. Okay, let's talk about 2, 6. 2, 6, I think, would be a tree. So basically, we go down to here and we say optional 1. Well, it is a tree now, so there is 1. So we'll call traverser of, oh, what was it? It's going to be 3, 9 or something like that now, plus 1. There will be the optional 1. So eventually we'll get down to a point where our coordinates are no longer within the field, right? Like we're at the bottom and we're like, oh, we're no longer within the field. So we'll just return 0. And then that's going to resolve all of these traverser calls, right? So it's going to say, oh, okay, so this was 0. The question was it 0 plus 0 or is it 0 plus 1? So all of the 1s are going to end up rolled up into this final number. It's a bit like doing a reduce on an array. Anyway, now that we've got this, we can delete everything but this const width thing. We do still need the width because of the modulus that we're doing. Although we could just sort of sneak that directly in here, but it feels a little cleaner to do it this way. Okay, so I'm just going to make this a little larger again, and we'll run the code. Hey, we're getting 7, so not bad. I would say the requirement for this to be functional has been met. Now, whether it's beautiful is another story. So basically, here's what I want to say. Since we can see that there's a return here and there's a return here, let's just make this a return. Okay, so we'll just say return, and then we'll ask ourselves this question: row is less than field.length, is it? And if it is, then we're going to return this, right? So this plus the optional 1. Well, optional 1 is just this thing, so I'm going to put that in as well. So plus, and then in here, that. Okay, so that's if it's true. And then if it's false, return 0. Okay, so that's a bit unruly, but once we save it, I'm sure it's going to look beautiful. I don't know if I'd call that beautiful, but anyway, it's looking more efficient. Sorry, I mean more efficient in terms of how many characters there are on the screen. But one thing I'll say is that anytime we're doing an arrow function, basically if we include these braces, the curly brackets, then it's not going to by default return what we have as the output. But if we get rid of those braces, we don't need to include return. It's like we're not doing anything before this, right? So yeah, we could just go ahead with this, and now this should hopefully, yeah, it's still running. It's giving us the value we're looking for. Okay, cool. So let's see. I mean, are we ready to actually apply this to the full problem here? It seems like it's working for our sample. So if we're confident in our code, we could go ahead and fetch the actual data here and then apply this same stuff to it. So I guess let's go ahead and do that. So first things first, I'm going to copy the link address to our puzzle input. And then we're going to go down here and we're going to say const response is assigned the value of await, fetch, and then our puzzle input. Okay. And then we'll say const response text is assigned the value of await response.text. Okay. And that should basically give us something where, yeah, exactly. We've got, whoops. I'll just go ahead and return that. Nice, okay, yeah. So we've got something that looks like the right kind of a thing, right? It's basically like this, well, it's a big string. It's not yet, like, notice this is all one string, right? So we might want to actually split that up. So I'm just going to say const field is assigned the value of response text dot split on the new line character. Okay, and I'm actually now just reminded of something that happened last time, which is that at the very end, we ended up getting an empty entry, an empty string. Yeah, exactly, because there was that extra new line at the end. I should have put a dot trim in there, but we have other ways to solve this. I'm just going to say field.pop. Okay, so keep in mind, .pop is a mutating method, so it will actually change the value of field. Just to make sure this worked properly, we're gonna dig into this, and yeah, it looks like it did lose one. So was it 324 before? Yeah, it was. Okay, perfect. So 323 is what it's meant to be. So, well, guess what? We've got field now. It's in the same format as what we had over here. It's just much, much larger. So we should be able to put all this stuff in. Actually, I'm just gonna copy this over, and then we'll just run traverser, because the console log there is pretty much implied. Okay, so we'll get this in here, and I'll just say traverser, we'll run it, and 167 looks to be the answer here. So let's go ahead and submit 167. Submit. Nice. Okay, looks like we got the right answer. We're one gold star closer to saving our vacation. So let's continue to part 2. Now, I love a problem like this that allows us to reuse some of the code we wrote in the first place, and it rewards modularity the first time around. So basically, we're trying to do the same thing now. So same field, we're starting at the same place. The only difference is that we're no longer just hard coding in this write 3 down 1 rule. Instead, we want to accommodate for many different possible rules. So, or directions, I should say. Yeah. Anyway, the point is, what we're going to do is, we're going to try 2 strategies. So the first thing we're going to try to do is to basically modify the function that we have right now, and then make it so that it'll accommodate whatever directions we want to head in. So I guess before we even do that, I'll just say const directions. I'm just going to make this an array of 2-element arrays. Okay, so I'm just going to prepare those. I think there are 5 of them. So it says write 1 down 1, but keep in mind the first coordinate is going to be the vertical one, right? Like the row coordinate is going to be the vertical one. So I'm going to make this 1 1, and then for this next one, write 3 down 1. Well, that's the one we've already done. So basically 1 3. So the change in row is going to be 1. The change in column is going to be 3. I'm just trying to respect the same order as we had with our row and column in the function before. So 1 5, 1 7, and then 2 1. This could be an interesting one because notice now we're skipping 2 rows at a time. So we might actually like skip over the end of the array. If you wrote your code in such a way that you were just checking to see if you were on the final row, this one might mess you up. Okay, so we've got all our directions. I think we've got it copied over, so I'll just go full screen with this. So we have our traverser function. Now, what I want to do is basically, I want to do this in 2 ways. So the first way is I want to just modify the traverser function to take additional inputs. So I'm going to say d row and d call. This is kind of like, dx and dy, like the change in x, change in y, change in row, change in column. So I'm saying d for delta. If I could put a little triangle symbol, I would. I guess I could use an emoji or something like that, but it might mess up the monospaceness of this font, so I'm not going to risk it. Okay, so the delta row, delta call, basically that's what we're going to have here. So row plus d row, and then call plus d call. Okay, so then the only other things we need to do is, first thing, I'm going to actually put these at the start of the function, and the reason is because we have optional variables afterwards. So at the end, we have these ones. We don't need to include these if we don't want to, because they already have values. Now, what that also means is we're going to have to make sure to put these 2 variables in every time we call traverser. Otherwise, it could have very unexpected results. Because the way I had it before, it would be passing in row plus d row as d row, and then call plus d call as d call, and then 0 and 0 for row and call. So that would be really weird. Okay, so we've got these in here, and now the only other thing is we want to say, like, for traverser, we want to give it the d row and d call. So I think 1, 3 was the first one that we had before, right? So we're going to save this and we're going to try to run this again. And yeah, it's still 7. Okay, so 7 is the number we should expect from this one. Did they give us the numbers that we should expect for these others? Yeah, okay, so 2, 7, 3, 4, 2. You know what? I think I want to check these all at once. Okay, so instead of just returning, instead of console logging traverser, we're going to console log directions.map. Actually, hold on, let's do this in like a 2-step kind of way. So const tree counts, let's call it. Okay, we're going to make a new array, and it's going to be a map of these directions. What do we have in each of these directions? What are the values we have? Well, we have these little 2-element arrays, right? And they represent a delta row and a delta call. Okay, great. So we get these two things, and then we can basically just say return the value of traverser with that d row and d call values in there. Okay. So we could just do something like that. We'll get our tree counts array, and hopefully, provided we did this right, whoops, tree counts is not a function. We should get, whoops, let me just split the screen. Yeah, sorry, this is what I was looking at before. We should get these values, 2, 7, 3, 4, and 2 respectively. And then basically when we want to answer the question, we're just going to multiply all those together, and that's how we're going to prove our understanding. Okay, so we're going to save that, and now let's run it. Okay, yeah, so what were those values again? 2, 7, 3, 4, 2. Hey, looks good. And we could even say, let's multiply these all together. So we'll do a dot reduce, and then we'll say product and num. And we'll just do product times num with a starting value of 1, just to be safe. The starting value is something you really want to put in there just in case there's going to be an empty array. So we don't have to worry too much about that, but why not? And it is 336, and I'm realizing since I have my split screen on, you maybe couldn't see the entire thing I was just typing, so sorry about that. I'll just say final product, I guess. Final product is going to be this, the result of this big reduce here. So let's just take that and say assign the value of this, and then we could even do both. We could console log both of these things. We'd say console log tree counts, and then console log final product. Okay, so we'll save that and run this. Yeah, cool. So that's nice. We get the individual values as well as the resulting product here. So this is pretty good, I think. It feels very functional to me. I guess one thing I'm wondering, now this is maybe a bit of a theme, and we'll try to keep this up. So far I've had a question for you, my dear viewer. I've had a question for you in each of the previous videos, and I have one for you now too. It's a question about functional programming and what's considered a side effect. So something I'm noticing is basically I'm kind of reaching outside of traverser here, and we're accessing field. Now we're not making a modification to field, but we are reading its value. I'm kind of wondering if it would be more proper to slide in field as one of our inputs here, and then continue passing it in to the next ones. I'm not sure if that would be, I feel like it's probably not a side effect, but it might be a trespassing of scope. Anyway, I'd like to know definitively what the more proper way would be. Certainly, if this was like something where field was not within the scope where this function was defined, we would definitely want to pass it in here. But yeah, I'm not really sure what would be considered more proper in this case. So if anyone has an answer, definitely feel free to leave that in the comments below. I'd love to hear from you. As for now, I want to talk a little bit about the concept of a higher order function. Now, this is a really important concept in JavaScript and in many programming languages. And in order to answer the question of what it is, let's talk just sort of more broadly about what a function is. Okay, so we could think of a function as like something that does something. We could think about it in sort of the math sense as being like an input-output system. There are lots of ways we can think about a function, but let's just consider in terms of functional programming. In terms of functional programming, no side effects. Basically, the idea that you just feed in information and it spits out other information. Basically, what that tells us is that in terms of functional programming, we can think of a function in terms of something that has an input and an output. Okay, and that's part of the reason I really like these arrow functions. We have the input here, we have the output here. It's all very clear as opposed to like, function, open parenthesis, like, you know what I mean? The syntax makes it pretty clear how to follow this, right? This is something that takes two inputs called product and num respectively, and it returns an output of product times num. Okay, so let's think about what these are, like in terms of data types. This is a function that takes two integers and returns one integer. Okay, this is a function that takes one array of two elements and returns an integer. Okay, so we could mess around with the different data types we have. But the question is, what if one of those data types was actually a function? So we're talking about the idea of a function that takes another function either as an input or produces it as an output. Okay, so on one end of the function, it's producing or accepting another function. So it's a bit meta. And we call it higher order functions. We don't just call it second order functions because like we could keep nesting these, right? We could have a function that returns a function that returns a function that takes a function as an input that returns a function. So there are lots of levels to this, but basically the idea is we've actually already seen a few higher order functions. In fact, we have a few of them on our screen already. Keep in mind, like map is a function, reduce is a function. We're calling them. We can tell that because of the parentheses that we're putting after them. We're invoking this function. And what are we giving the function as an input? Well, we're giving it another function, something that has an input and output, a callback, right? So basically, these are functions that accept functions as their input. So these would be examples of higher order functions. I now want to talk about higher order functions that are the opposite type, so ones that produce a function as their result. Okay, so the way we're going to do that is we're going to make a new function called generate traverser. Okay, and this thing is going to take a delta row and a delta call as its inputs, and it's going to return as its output this whole function, okay? So I'm going to take this, I'll just hold Alt and arrow up. Ooh, and it even maintains the indents. That's beautiful. Okay, so we've got traverser. Now keep in mind, drow, dcall, these are no longer coming from this function, or they're no longer being sent to this function. We already have these. They're defined in the scope of the outside here. And this is kind of an interesting thing in JavaScript, that this function that we're going to return, traverser. I'm not going to get too in-depth about this because it's kind of an interesting concept, but like basically this traverser function will have memories of the scope where it was born. So like we could, for example, say like, let I be assigned the value of 0. And like, every time we call this function, we could do like an I++ or something like that, and then console log it. And it would actually remember that, it would be able to say like, oh, this is the first time you've run this function. This is the second time you've run this function. Like we could have functions that have memories that come from these phantom scopes, from functions that have already completed and, we've long forgotten about, but there are the function that was produced from it has memories of the environment that it was born in. Anyway, the point is we've got this thing generate traverser now. So this is a function. Actually, let's make a comment about that. So this is a function that returns a function. Okay, so it's a higher order function. Traverser is the function that it returns, and notice drow and dcall are not being sent to traverser. They're only being sent to generate traverser. Okay, so basically now each one of these directions is going to have its own bespoke function. Okay, so I'm going to say generate traverser now instead of traverser. I'm kind of regretting that name. I should have gone with something with fewer syllables. But anyway, we've got generate traverser. So now tree counts should actually be returning a function. Okay, so I'm just going to comment out this part and the final product over here. And I just want to do this so we can see what this output looks like. a bunch of functions. Each one is a traverser function, but keep in mind, every one of them is a different traverser function. They have different drow and dcall values, okay? So we don't actually want functions within this array. We want the results of those functions. So we're not just going to generate this function. We're going to call the function. It might look super weird seeing a set of parentheses open and close followed by another set directly after open and close. But I mean, basically, this is a function, right? We're calling this thing, it returns a function, we're gonna call that function. You know, we could say like const traverser is assign the value of this, and on the next line, call that traverser thing. But I trust you, dear viewer, I trust that you're following along here. So I'm just gonna go with this. And if I'm wrong about that, feel free to leave a comment asking your question below. Oh no. Okay, what has happened here? I seem to have made a mistake. Is it the fact that I put a semicolon in here? Yeah, that semicolon actually would be a bad idea because I didn't put the braces around this. So yeah, I should not have that semicolon. Okay, so let's run this, and there we go. We're getting the numbers. I think they were the same as before. 27342 looks good. Okay, perfect. So yeah, we can get our final product thing back in here. Console log that. We'll save this all up and we'll run it. And there we go. We're getting our 336 value that we were hoping for before. Nice. Okay, so now we have this sort of, yeah, kind of like a nested function. It's a function that returns functions. It's like a function factory, right? We just order up the function according to what deltas it should have, and then it's going to say, okay, cool, here you go. Feel free to call this anytime. Another thing we could do is we could just make this a function that comes up with the traverser function and then calls that and gets the result of it and then returns that. You know, like there are many ways to pet a cat. We could arrange this in many various different ways. But anyway, what we want to do for now is actually answer the question. So we're going to go back to our split screen. We're going to we're going to load up our console, and we're going to do our response is await fetch. Oh, I need to get my puzzle input again. Copy and link address. I'm assuming something else is on my clipboard by now. Okay, so we've got that, and then we'll say const response text. Ooh, I forgot to put const before that. Well, I'm sure it'll be fine. Okay, so response.text. Remember, we put the await there because this is an asynchronous function. We'll say const field. This time I'm going to remember to trim it. So we'll say response text.trim.split. Trim is basically just removing that white space character at the end so that we don't have to pop an element off the field. Let's just make sure field worked okay. Yeah, I remember 323 was the right number of rows from the last time. So the only thing left to do then is to basically grab all of this. And we might as well just go ahead and include the comments. So, okay, perfect. We'll paste all of that in, and basically final product should be our answer. Oh, directions is not defined. You know what? That's true. Oh boy. Now that's the problem with doing this stuff inside the console here. Oh yeah, we don't have width either. Yeah, okay, so I forgot to paste some stuff in. Now because I was using constants, I would have to like reassign those. So I'm just gonna sort of recreate what we had before. There we go. So we've got our field. And now, yeah, we'll just grab the width, directions, all this nice stuff, everything down to the console logs. We'll paste that all in, and hopefully we don't get an error this time. Perfect. Final product. Whoa, okay, it's a huge number. Maybe we should take a look at tree counts. Part of the reason I want to check tree counts is this will tell us if the, I think it was the second one, yeah, the like index 1 value should be the number we got in the first one. So what was that number? I don't quite remember. Yeah, 167, that sounds about right. Okay, so we'll just take this big product and we'll paste it in here, and we'll go ahead and submit that. Yeah, hopefully this is all good. Nice. Okay, we got the right answer. So, good stuff. This is a really fun challenge. I really enjoyed just how many different ways we were able to sort of rearrange this function stuff. And, you know, you've got to love a good discussion about higher order functions. They're such an interesting concept, and as I was saying before, we can just sort of extrapolate these. You know, you can have functions within functions within functions. You can have a lot of fun with this kind of stuff. Okay, so nice job solving the problem. Amazing work as always. I look forward to seeing you in the next video for day 4. I'm sure it's going to be a fun one. And in the meantime, remember to believe in yourself. Anything's possible. See ya.